Hey guys, welcome to In Time Tech. I'm Venkat Krishna. I'm a software engineer and I'm here today to talk about the part 2 of our test driven development series. So, as I said, this is the part 2 of our series, and if you hadn't watched the part 1 yet, I highly recommend that you watch that first before you continue with this video. Okay, so that being said, let's begin. So, first, I'm going to talk about the styles of unit testing. Basically, unit testing is done in three styles. So you can see those three styles on the screen. So the first one, the output verification, you must have seen that in the part 1 video by Ritika. So in output verification, this is useful only in the functional style of programming, where you give an input and verify the output, which is predictable and does not have any side effects and gives the same output for an input no matter how many times it's run. And the second type or the style is state verification. So when we work with objects, we use state verification. So when we make an operation on an object and verify the state change of the object, that is when we verify if any state variables or data members of the object is changed. So that's state verification. And at the last is the collaboration verification. So we use collaboration verification when we have third-party dependencies and we want to ensure that the different parts of the system collaborate correctly. Say your object uses another object for some or other reason, or your object uses multiple objects for various reasons and you want to verify if they all work together properly. In this case, the collaborations are enforced and sequence of operations is what matters. So we'll see when to use collaboration verification and when not to in the coming slides. Okay, so let's see these styles in detail now. Okay, yeah. So before we dive into each of the styles of unit tests, we need a metric to evaluate how valuable those tests are. We need to measure which is the best style of testing and choose the styles based on ease and need of writing those tests. So let's look at what our metrics are. So tests that satisfies or has these four qualities that you see on the screen, or qualities or characteristics you see on the screen, can be called as valuable tests. So if you see, I have highlighted the first, catch regression errors, and the second, fast feedback. That's because these two are provided by all three styles of tests. So what is catching regression errors? So say you have perfectly running test. By the way, nothing is perfect in this world. You can always get to a better state. So you have a perfectly running test, and when you make changes in the code that is being tested, the test should not regress to the defective state. That is basically catching regression errors. Okay, all right. So now what do I mean by fast feedback? So in test driven development, we will be writing the test and code parallelly, switching between them in a 10 to 20 seconds cycle. So for every line of code we write, we should be running our test, and our test should run really fast, or else we'll be wasting our time in waiting for the test to run. But with modern computers and framework, it's not a big deal anymore. All the testing frameworks runs test in milliseconds, if not in microseconds. So most style of tests give fast feedback and catch regression errors given the tests are written properly. So that leaves us with the other 2 points: less false positives. The third one. What do I mean by false positives? So we write tests, or the function of a test is to catch a code failure. So when a test fails, it means it caught a defect or a code failure. This case is considered as positive case. But when a test fails, even though there is no defect in our code, then that will be called as a false positive. So this is something you should understand clearly. So if you have any doubts or questions, the comment section is made for that reason specifically. Just go ahead and post it there. Someone of us will get back. All right. So the next is low maintenance cost. Low maintenance, basically. So say you write a test now for a piece of code and then you refactor your code later. It should require little to no changes in your test. Also, if someone else reads your test, it should be understandable easily. Remember that your test code serves as a documentation to other developers. Setting up the test environment, adding new tests, correcting issues with the test should be easy even for new members in the team. So when your test, you know, satisfies these four qualities, then that will be called as a valuable test. Okay, so let's move ahead. All right, output verification. So as I said in the beginning, in the first slide, I guess, yeah, output verification is used in functional style of programming where where you verify the output of a function. Pretty straightforward, right? So it's a common saying that functional programming is the best way of programming, but it's not always possible to develop a software just following one way or one single principle, right? So, but again, nothing is possible, but it's not necessary, yeah. So functional style gives us the best protection against false positives. Little, to no false positives. It catches regression errors, gives immediate feedback, and very low maintenance cost for the developers, or by the developers. But how? You see, in functional programming, if a function satisfies these two conditions, then it is said to be a pure function, immutability and no side effects. So what do I mean by immutability? If a function is not dependent on a mutable data member or a state, then we will get the same output for the same input no matter how many times it's run. And the second one is no side effects. So side effects may include logging to the console or a file, reassigning a variable, mutating an object, changing the value state of an object, anything like that. So you see, I have got two, tiny examples for you there. So if you see this function, this is a pure function because it does nothing but just perform an addition of these two variables and return them. It does nothing more. So this is said to be a pure function. And this one is called impure, or it's said to be impure because if you see, this function returns a true or false, a boolean based on the required height variable, which is mutable. Say if I change the way, oops, sorry, yeah. Say if I change the value of this required height variable, in the code somewhere else in the code, and then this output may not be the same because this would have been changed, and it's not predictable. I mean, it will change. So yeah, so this is an impure function. So functional programming is a very vast topic, and if you want to know more about it, you know what to do. Just Google it. Maybe we will release a video on it later in the near future too. Yeah. All right. So that's about output verification. Let's go to the next slide. All right. So before we jump into the second style, that is state verification, there's something important to talk about. That is implementation detail. So we should never test the implementation detail of our system. Why? Okay, so before I answer that question, let's understand what is implementation detail. Suppose you have a function to sort the elements of an integer array, and the algorithm you are using is bubble sort. So that bubble sort is the implementation detail. How we implement our functionality is the implementation detail. And if we are testing the implementation detail, and when we, like, say for example, when we decide to change the algorithm, say, instead of heap sort, instead of bubble sort, you want heap sort or some interesting sort for better reasons, our test is going to fail now, and that is not a desirable outcome. Changing the algorithm data structures should never break your test. So yeah, never test the implementation detail, but test our functionality through a well defined public or open API. What is a public API? Well, public API can be defined by these 2 points here. It is a public API is something that addresses an immediate goal of the client code. Immediate goal of the client code has to achieve, and it addresses that goal completely, yielding a full result in one go. So when we write our classes, we should define proper public APIs to access our data members using the concepts like abstraction and encapsulation. So abstraction is where you abstract the data members by providing proper access specifiers according to your needs, and encapsulation is where you access them using public methods instead of directly modifying or changing them. Okay, so state verification. So state verification has good protection against false positives, and in state verification we verify using only public API. Okay, so this is like a rule we have to follow. There are basically two things. One is define a public API well and never make a private method public just to test it. If you do so, then that's the first indication that you have written code that is not very testable. And state verification has a little bit of maintenance cost than output verification, because we have to maintain our public API and we're not allowed to test our private methods and data members directly. So yeah, there's a reasonable maintenance cost. So I'll just show you a quick example. So if you see here, I have a class called file system component, and I have some private members, and I have few public API to access them or modify them. And I have a test here named check children. So what I'm doing here is I'm creating a file system component of the name child, and I'm setting that to my component. So this component is given to my test by this fixture. If you see here, uh, it's just another file system component in the name of test. So when I add this child to this component, that's my parent component, the state of that object is changed, because what I am doing is when I call the set child, if you see here, I'm just adding the new component, the child component, which is this, to my children vector of my parent component object. So now and then I will verify the state change, which is nothing but just getting the children back and then checking if that children vector has our child component. So this is a very basic example of state verification, where we verify if the state of the object has been changed or not. Okay, so before we go into collaboration verification, there is something which we all should know about. That is the ports and adapters architecture. So this architecture is about how we separate our code, the business logic from other components in our application. So the core of an application is where the business logic of the application happens, or is it, the business logic of the application. So the core receives data, performs operations on it. Optionally, it may communicate with other external parties like databases or persistent entities. This notification services. Like that. And then there are application services which we use to communicate with our core through well-defined interfaces. On a high level, these interfaces are called as the ports, and the services which implement these ports are said to be the adapters. So these application services communicate with our domain model, and the domain model internally may communicate with other services or any external services such as databases, notification services, or any third-party services. So the important thing is these application services doesn't have any business logic, and we won't be testing this as much as we test our business logic. So basically the core is what we need to test, not the services. Okay, so that's about ports and adapters, and this will be useful when we go into the collaboration verification. Okay, so now we will be looking into collaboration verification in detail. Okay, so look at this diagram here. The add product method is being called on the order class, and the order class internally calls this update last bought product method on the user class, and both the classes changes their state into a different state. So now if I want to verify this, if I verify this update last bought product method, I mean, if it is being called or not, then that will be the collaboration verification. Let me show you this in code. All right, so I have a sample test here. So if you see in this, I have various objects like user, order, and then a product, and then I'm using sign in to mock my user object, and I'm expecting if this method update last bought product have been called at least once, and then I'm adding the product to my order, and then I'm actually expecting if this has been called. I mean, I'm expecting if that function has been called on that mock. I'm verifying it. Okay, so let's see inside what's in my order. Sorry, what's inside my add product method. So if you see here, I'm adding the product to the products array, and then I'm calling the update last bought product method on the user object. Okay, so oops. So there is a problem in this uh, code, in this test, I would say. Is this update last bought product is an implementation detail? I would recommend you to pause the video and think for some time before I tell you the answer. So yeah, this is an implementation detail, because tomorrow someone else may come and refactor this code, and they may decide, I mean, you may decide that, or you may decide that you don't want to update the last bought product here. You may refactor the whole order class or the user class, and you may change how you want to update the last bought product. So yeah, that's an implementation detail, and as I said before, we shouldn't verify our implementation detail. So then how do we verify if our product has been added to the order? If we see inside our order class, we have one more method called total amount. So when we add add a product to our order, it's definitely going to change the total amount. So let's verify that, which is nothing but our order object's state change. I have already written it, I'm just uncommenting the line. So if you see here, this product's price is 100, and then when we add it to our order, this order's total amount should equals to 100. Pretty straightforward state verification. So yeah, we should never test our communication pattern inside our class. Okay, I'll just run and show you this. Yep, it's passing. Yeah, so we don't do collaboration verification inside our domain model. We do only state verification. Now you may be thinking, where do we do collaboration verification then? So collaboration verification is used when it is necessary to maintain backward compatibility. And where do we need them is when we are interacting with the repository layer, or any third party system, message bus. So now here communication pattern is not an implementation detail. When we test this communication with the external services, it is not an implementation detail. So even in in ports and adapters itself, we say that we have to wrap our external dependencies. Like if you have a payment gateway, you have to wrap that in your payment interface. So you would have created an interface, and another team might be developing it, but you will make sure that it is wrapped. So I'll show you that. All right. So if you see here, I have an order service in which I have a method called submit. So whenever we submit an order, that it should be charged. I mean, we should pay for our order basically, right? So there will be some other operations obviously in the submit method, and then ultimately it will call this charge payment method on this gateway interface. So this is an interface which has been injected, which I'm injecting in this order service as a dependency. So if we sorry, we see okay, we see inside this, it's all pure abstract. no implementation, it's just a interface. So basically, when we are writing this submit method, when we are writing this order service class, someone else or some other team might be implementing our payment gateway. We don't When we are writing this order service, it might not even be there yet. So if we see this test, same like I have an user and I have a mock payment gateway, which inside I have a empty charge payment method, which does basically nothing, because it's just I'm just mocking it for this test to for this to I mean for to test, sorry. So yeah, and then an order. So I have a product, and then I'm adding the product, and then I'm mocking my payment gateway and expecting that if this charge payment method had been called at least once. Okay, so and then I'm creating a service, order service, and then I'm submitting the order. So when we submit this method charge payment should be called. I'm verifying that here. So when we look inside our order service, this gateway, this charge payment method on this interface, if we comment this out, will our tests pass? Let's see. Nope, it failed. And this is a true positive. This is not a false positive, because this is not an implementation detail or anything like that. Where is it? Yeah, it's because whenever we submit an order, that order should be charged. You should have paid for that order. So if we don't call the charge payment, then our tests should fail. So this is an example for collaboration verification, where this order method, see, it passes. See, the order method and the order service sorry, the order service method and the payment gateway, how they are collaborating. Basically, this is an example for collaboration verification. So this is collaboration verification, where we test how our external dependencies are called, and we verify if they are being called properly or not. All right. Thank you.